Okay, so if you recall from our linked list class, what we have was we created our linked int list class, we created our list node class, and we created our client class to test. So if you recall, as you can see, your public class linked int list. So this is your class. You are creating the linked list class already built in. So Java has already created the linked list class, and you don't have to write this add method. You don't have to write the toString method. You don't have to write any other remove or contains, get, any of those methods. You just recreated with a new name known as linked int list, in which shows that it is for only integers. And you can do it with your strings. You can do it with your characters, boolean, anything you want. You can create your linked list class. But the way we did, we just did or recreated was, the concept was to understand how this built-in classes are created at the back end. If you can see, this was your linked int list class where you created the front. So if from linked list, we have identified that front was important, the start of the list. If front is null, it means you don't have a list. If your front is not null, all the method determined with front. So if front is not null, create the front with a new data value, and otherwise go through the front and go through till the end of the list and add this new data value. Simply same as to print that your linked list. You cannot simply print and say system.out.println and print the list. All the data structures comes with the toString method, where you have to, because they are objects, when you have to print the objects are printed with the toString methods, and you have to write those toString method. Again, our front was important. We tested if front is null, then throw the exception that we don't have anything to print. If your front is not null, go through the whole list and print all the data value one by one. You can say it's your choice. You can simply write system.out.println here and you can print. Otherwise, you can return a string by concatenating all the data values in your linked list. And how we started with our list node class. In your list node class, what you had was you have to identify what your list node consists of. So your list node, you said, consists of the data value, and it will have the address for the next node. So that's how you created. These were the two fields you identified, that what was the requirement, and then how to assign the values. You created constructors. And how constructors are created, that was discussed in chapter 9 when we talked about inheritance. The constructors are based basically on your fields, number of fields you have, and how you can assign in multiple ways the data value. User may just give you the data value. So there is one constructor for int data. User may give you the data and the address that added in the middle. There you have this list node constructor where you are asking the data and the address. You cannot have the address and there is no data value, because the whole concept of list node is to have the data value and then the address. So that's why there is no third constructor asking for just address, because what we gonna do with the address? The address always comes with the data, and data can always come because it will add at the end and make your next as null. That this is add the value at the end of the list and make it null. So, and this list node is used if you want to add it in the front, or if you want to add your list node in the middle somewhere. Okay, so now in the same way, we will recreate our binary tree class. So how binary tree, what are the changes? So let's create a new class, right click and say new class. And our class name will be new class, and our class name will be IntTree node. Just like list node, we will start with our IntTree node. Now, what were the changes you saw in your IntTree node class? In your IntTree node, now what do we have? We have, first thing is identify the fields. What are the fields? What are the fields we have? We have data value, which will be public. Okay, public int, because it's IntTree node. We are working on IntTree node class int, and give it a name as data. Now, what is the change you have seen? Spelling. What is the change you have seen related to the list node class? In list node, we only had one address, right? And how you were identifying or mentioning the data type for that address was you were saying the same list node and then next, right? Over here, the address is about the IntTree node, the next node we have. So the data type will be IntTree node, and you can name it as now how the address is split or differentiated. Now we have, when you take a look at your tree node, what you have on your tree node. This is your tree node or root looks like, where you have, for example, if you have a value, then you have a left address and a right address, right? So now it's not simple like linked list where you had one address and you're just pointing it to the one node. Now you have two addresses. So if you don't have values, it means they will be null, but it doesn't mean that they are gone. If they don't have any values on your left side or right side, they will be null. Okay, so here are all the drawings. In tree node, now we have left, comma, we have public, in tree node, right, and semicolon. Okay, now we have identified our fields. That's field, the IntTree node field consists of data value and the addresses. Now we have to find the way to assign the values to these fields, and the way is creating constructors. So how many constructors we can create? How you create a constructor? Constructors are always public. They don't have a return type, not even void. They have the same class name. So the same class name is IntTree node. IntTree node and parentheses, what we are asking, is there a possibility that user say, okay, I just know the value and I don't know the left and right location? Is that a possibility? Yes or no? Respond in the chat, yes or no. Is there a possibility? How many constructors and how to create constructors? How you will identify the constructors? What will be the parameters in this constructor? Any guess? The parameter of constructors are related to your fields. So what fields do you have? Your first field is what you're asking. The purpose of the constructor is when user will create the object of this IntTree node, it will say new and it will pass the value, right? So we need the value. So there is a possibility that user will say int data only, that I just know add 5 or add 6 to this field. And what we will do is we will using this reference, and there is another before creating inside the details, what other constructor we have. The other constructor may be that user give you the left and right address that you are adding the values, and user has the left address and the right address of that value. So in tree node, how you create another constructor, same as the class name, but number of parameters will be different. And what parameters you identify? By number of fields. So in tree data, int data, we can ask in data, we can ask in tree node left, comma, in tree node right. And if you recall this reference, what we do is this dot data UR equals to data, and this dot left equals to left, and this dot right equals to right. After using this references, we can easily just recall, we can pass the value this to our reference to this constructor. You can use the reference to pass it values to your constructor as well, that we have the data, and for left and right, I'm passing or assigning the value null. Instead of writing all these three again over here and making left and right as null, we can just simply call our using our diffs reference, we can pass the values to this constructor and it will assign the values to our left and right fields. This is all about your IntTree node class. So after creating your IntTree node, our next task is that we have to create our IntTree class, right? Our IntTree class is what our IntTree class does. IntTree class, just like your linked int list class, we will create IntTree just class where you will be new class. And the third class will be a client class where we will be testing our code. So our IntTree class is in the middle, and it's like connecting it with the client and connecting it with the IntTree node. Our client cannot connect with the IntTree node class directly. So that's why our fields are public, because client have no idea that there exists an IntTree node class. So we will create our IntTree class, IntTree, and what IntTree class for, just like if you recall from your linked int list class, first of all, you have to identify, if you recall public class linked int list, you have to identify who is the kind of in other words, I would say, who's the boss of this list. So you will say front, because without front, you don't have a linked list, right? Your front is null, there is no list. Your front is having a value, go through the front. If you want to add a value, remove a value, go through this front. Who is the boss in your IntTree class, in your trees? If I create a tree, who knows who's the boss? Like, who knows that there is a tree, and if that person don't exist, there is no tree. If you make it null, the whole tree is gone. Who's that person in your tree? It was discussed in our last class. Who's the boss in your tree? Who we are calling the boss in the tree? Root. Yes, exactly. We are making root as our is the boss. If you make your root null, it means your whole tree is gone. If you have to go through and find the even number in your tree, you have to go through the root. If your root is not null, then go through the tree. If your root has some values, then if you want to add a value, check with the root, right? You have to do everything with the root to find the values. Okay, so now let's check IntTree, and that root will be private. Private, what's the data type for that root? What's the data type? How you create the IntTree class? How this class is connected with your IntTree node? How you will connect this class with IntTree node? By creating the IntTree node object here, a variable who will be connected or in charge, IntTree node, and give it a name as overall root, means that he is the overall root of your spelling mistake. Okay, IntTree node and overall root. Now, whatever you have to do, whatever the method you have to write, you have to check with this overall root. If this overall root has the value, is this overall root is null? If this overall root, whatever you want to do with overall root, you have to talk with this overall root. Okay, any question at this point? Any questions so far? Why we created two classes? No? No questions? Okay, now we have to write the constructor. Constructor for our overall root. So how you write the constructor? Same, they're public, same as class name IntTree, and we will be creating a default constructor. And what this will do is it will just make our overall root, all capital to memorize it, equals to null. That's it. It's not doing anything special. We are not asking for the values as user create the object, because user will use our add method to add the values into our tree. Okay, so now what's next? What method? Let's write the add method so that we can test as well at the same time. Now, how to write the add method? When you add, so we will be using the binary search tree. So if you recall binary search tree was it was sorted. So if the value is less than, if the root dot data is less than the value, we will add the value to the right side. If the value root dot data is greater than the value, we will add it to the left side, right? Correct? So let's write first thing. Now, one more thing I have to discuss about is the public and private, which was encryption. If you recall encryption, we had why we created this private keyword. Remember the encryption, we were making our fields as private. So if you are making your field as private, you have to write or give if you want to give access to user, you have to use the getter and setter methods. So if you're using getters and setter methods, it means your fields are private and you don't want to give access to the user. Now we will apply encryption to our methods as well. So there will be every time, and this strategy you can apply to all previous concept, even if you're doing a linked list programming question, whether you're doing array list programming question, this strategy must be applied to all previous concept. And what is the strategy? The strategy is that we will create two methods. One is public, which is user accessible, which our client will call, and the other method will be private, which will have all of our coding. Our public method will only make a call to our private method, and our private method will be all hidden and only is accessible in this class, not outside. Client cannot call our private method. And how to make it? Let's get started with our add method to see. First thing is public. As we are writing our add method, so what's the return type? What do you think will be the return type for add method? If someone wants to add value to your binary search tree, how that return, what do you think will be the return in that case? Are we returning anything? Is it void? Are we returning the same value? What we are doing? What is the return? Void. We are not returning anything. Why we are returning? We are not returning. We are just taking the value from user. It's an add method. We are taking the value and we are adding it to a tree, right? And add method, how we are adding the value, user will just simply give you the value, int value. Hey, this is the value, and add to the tree. Now this is your public method, right? Your public method will make or pass this value, because your public method know what value is passed by the user. And what you will do is you will pass it to your overall, the private method. So your private method is add, and you will pass it to add another method. So if you recall, right, like this, if you write your private method private, it will be same as void, and it will be add. Let me show you. And int value. If you do this, there is an error because number of parameters is same, method name is same, you cannot have same method name, right? So what you will do is, what we are asking, another thing is, which tree is it? Which overall root, what value you want to add, what is going on, like what I'm supposed to do. So you're saying, hey, int value, add method, take this value, and what else you are asking for is IntTree node, node and root. So this is the root we are passing you. And what root is it? So when you make a call from private, so add, you will pass the value first, value comma overall root is the one who knows everything, who have the public access. So overall root and semicolon. So the value user has passed add is gone over here in your private method with the value, and you have to add it to this overall root, which already existed or maybe not existed. So this root is the one. Now inside, how to add the value to your tree will be written in private method over here. Now, when it comes to binary tree, you have already seen the mixture of linked list and as mentioned, it was a mixture of linked list and recursion. You have already seen how it is linked list, right? You have already seen it was node, one more address is added, and now you have two addresses, and this half of the code is part of your linked list, which you have already done in your linked list class, right? You created list node, you created the next method, and what we just did new stuff is just we, instead of doing next, we have done left and right addresses, because now we have two addresses. So this was all connected to the linked list scenario. Now, when it comes to the coding scenario, here you will be using, instead of for loop, instead of while loop, there is no for loop, there is no while loop. We will be using recursion. And now how to add, remember, in linked list, if you add a value, you just simply write for loop, go start with I, go till the end, or no, you were using while loop, right? You were using for loop with array list. So array list, if you have array list, you were using I, start with 0 index, go till the end of the list, length -1 or length, right? And then when linked list, you used while loops. And you were like, hey, this is while your linked list is not null, current is not null, or front is not null, whatever, according to your question. So now you have binary trees. So you have left scenario and right scenario. And what we are looking for is we have to come up with the recursion to run a loop. Now, how recall your concept about recursion, what recursion is, how we do recursion, what is the purpose of recursion, what was it, right? In recursion, we had the base case and the recursive case. The base case, your recursive case must meet your base case and end your code. Otherwise, it will be an infinite loop. So what we do is we first of all identify your base case. It must be simple, right? What your base case will be in your add method. So we are doing with the binary search tree, and your tree is sorted. If your root, so simple as what you have done with your linked list. If your front is null, first thing, if users say, hey, add this value to a tree, you need to check, hey, if there is a tree or not. If there is a tree, how you identify if there is a tree? With this root, if you have a root which is passed here. So if your root is null, then what? If your root is null, that's your first if condition. If your root is null, that's your first if condition, right? What if your root is null? There is no point of doing recursion. There is no point of writing loops and anything. Your root is null. If your root is equals to null, then what? Throw an exception, error. If your root is null, then what? This is the case. If your root is null, there is no values in your root, and user has given you a value to add in your tree. What you will do? Use the chat. I will start calling names. You just have to make a guess. Wrong guesses, I need full-on participation. Otherwise, this is a very hard concept to absorb if you're not participating or not making any suggestions or guesses. If your root is null, this is the scenario. If your root is null, user has given you 5. Value is 5. Add 5 to the tree. Where this 5 will go to? If your root equals null, should I throw an exception, error, return 0? What do you think? If your root is null, root will be equals to 5. 5 as root, return 0 to a new IntTree node. That's what we have to do. If your root is null, this is not simple variable. This root is not a simple variable. Don't treat it like simple variable. This root is very important and something else. If you have to give something to root, if root is null, which is like this, we will say, hey, root, you are equals to new IntTree node. Remember how you created list? You cannot simply say, hey, root, you are equals to 5. That's like a variable in memory like this, and 5, and this, which was int a, like that. You cannot treat int a and root as the same thing. This is root. This comes with 2 addresses which you have to create. How you will create? By saying new IntTree node, which will IntTree node, which class? It will go in your IntTree node class which you created. Now new IntTree node and parentheses. This is your first constructor you created in your IntTree node class. You're saying, hey, root, you are equals to new, put a space, new IntTree node, and this is the value. So after this line, what just happened is it created a new IntTree node, root, because your root was null. There was nothing. It created this root, assigned 5 because value was 5. You said IntTree node equals to 5, and then left is null, and right is null, like that. So this is after this is what has happened. Okay. Now, else if is the case when your root is not null. For example, the same one, your root is not null, it's holding 5, your root is not null. So it means else if what? If your root is not null and there's a second run of this code and user said add, let's say, add 7. Value is 7. User said add 7. You came here, you're like, hey, value 7 in tree node root, which this whole tree is passed, and you check if root equals null, and this is false. Your root is not null. Else if is the case. Now, how to add 7 to this tree? How you will add 7? This is a binary search tree. So you will check if root.data, else if is the case, yes. If root.data is less than value or greater than value? Less, because it's 7, right? So we will root.data is less than value, which is 5 is less than 7. Then what we have to do? So it's less than value, starting curly braces, ending curly braces. Now it's very important. Okay, I'm talking very slow just to make sure that you understand the concept of recursion. This is what you have identified as the base case. Now we have to write the recursive case, because this is a loop which you have to convert. If root.data is less than value, because your root is not null, it means we don't know how big the tree is. This is, we can see that this is like this, but when user is keep on adding value, we don't know how big the tree is. It means keep on running as long you don't have the value. So if root.data, which is value, is less than 7, so 7 will go on which side? Right side or left side? This is left, this is right. Root will go on to the right side. So you have to make your root move. This is your root. Your root is currently 5. So it means you have to make your root move to the right side. So you will say your root dot go to the right side. You are equals to call the add method, which is the same private method you will call. You will pass the value. You cannot change the value, right? You cannot change the value. But remember, what is the rule for the recursive case? The recursive case is how you call the recursion. You call the same method name, that's what we are calling, and you pass the values. And one of the value must increase or decrease depending on your base case so that it meets this case. Otherwise, it will be an infinite loop. Every time it will recall, go add method, go to the add method, and it will keep on running, right? As long you are going in else if. So it means we cannot change the value, right? Value cannot be changed. User said add 7. We cannot change the value. Value will be passed as it is. But what we have to change it, we have to go through our tree. How big is the tree, and find the right spot for the root. And then if the root is null, then make a new IntTree node and add the value. So root.write, you are equals to add value. And what root will be? If I just simply say, hey, root, it's the same root. 5 is passing. I have to change. I have to say root.write. Root, move to the right side of your tree and go and find the value. Does it make sense? Oh. Root.write, you are equals to add. Okay, pass the value, same, comma, and you will pass root dot. Okay, root.write, you are equals to add root.write, comma, value, comma, root.write. Okay, now else if, another case. What is your next case? Now, what is your next case? What if user has given you 3? User has given you 3. Where 3 will go? Else if will be the case. Else if root.data is greater than the value. So 5 is greater than 3. It means we have to go root dot left side, you are equals to what? Add method, create the recursion. Now pass the value, because we don't know how much left we have to go, how we have to compare the root again and again. We will do a dry run of this so that we can understand the concept. Value, comma, root dot left and semicolon. After all this, we have to make a return to our root. We have to return our root because now we have a new root. So it means our private method will not be void. What it will hold, what it's returning root. What's the data type of root? If I'm returning root, return root. So what is the data type for this root? This root, what's the data type? What's the data type of this root? Come on, class, what's IntTree node? As you can see, it's right here, IntTree node. So it means it will not be void because your root is changed now. Your root has a new tree. So it will be int, you are returning IntTree node. You are returning a whole tree again. And when you are returning it here, so you need someone to catch it. Otherwise, there is no point of making a return who's making a call. So where you need to update, you need to update this overall root with this method that catch and update your tree, because this overall root is the main root. So if you have made a call to add method, it did some changes, added some values and return the new tree, and this new overall root is being updated. Okay, so let me check my curly braces, starting, ending, let's say one more, I think. Okay, let's do a dry run. Okay, let's do a dry run of this method so that we can see. Let's clear all the drawings. Let me pick the red color. Okay, let's assume there is nothing here. There is nothing. And what we are starting with, public int overall root. Your overall root is null, which is holding overall root is null. This is what we have. Overall root is null. User has given you 5. Or let's make a bigger value, 8. Your value, user said, hey, add and value. User said add 8. Your value is, oops, 8 is so hard to write with this. 8. Your value is 8. So overall root equals to add method you're passing and making a call. And after this, your control transfers here. Your value is 8 and your root is null, right? Because there's nothing in your overall root, which is empty like this. Oops. Empty. And you have said root equals to null. Now you will check if your root equals to null. Yes, root is null. Then root UR equals to, which is null right now, new IntTree node. And how you create an IntTree node? You create IntTree node like this, and you add the value, which is 8. 8 becomes the root, and have left and right address, which is null. Okay. Use the chat if you're confused at any point, do let me know. Okay, so if this condition is true, it will not check rest of the condition. It will return your root. Your root is now this one, and it returns over here as IntTree node, and overall root is updated. So this is what your overall root looks like. This is your overall root. Okay, now user has made a call. User said again, user said, I want to add, I made a call here with the public method. User said add, this time add 11. Value is 11. As you go inside, you have overall root equals to add. So you are passing your overall root. Now you're passing this whole tree. Remember previously it was empty. Now you're passing this whole tree. This is your overall root. You're passing it. with the value 11. Now you go inside in your private method, you have value 11, and your overall tree, it's not null this time, it's something over here. And now you check if your root equals to null. Is your root null? Nope, root is not null. Then you will go in else if. Now when you go in else if, you have root dot data. Root dot data is 8. Is 8 is less than value. What is value? Value is 11. Yes, this else if is true. Root dot data is less than value. Then it means we will run this part. And you said root dot write. Okay, so previously was supposed to just write R for root. Your root was pointing at 8. That's why you said root dot data. When you said root dot data, where is it? Where it go? Over here in your else if. When you said root dot data, it showed 8, and it checked is less than value. It says yes, 8 is less than value, which is 11. You said okay. Now update it to root dot write. So this is your right side. So root dot write. So root is now shifted to this right side. Now your root is pointing over here. Now you go again IntTree node root, and you have value. You check if your root equals to null. Yes, my root is null. So you said, okay, root, you are equals to new IntTree node. And how you create the IntTree node? How you create the IntTree node? You say new IntTree node and you pass the value. How you create new IntTree node? Like this, and new IntTree node have left and right, and you are passing the value to the data value, add the value, which is 11, and left and rights are null. And then again, when you went into the base case, so it means return root. When as you go to the base case, it's a stop. There is no recursion. Recursion is only when you have making a method call. There is no method call here. After running this statement, it will end. Return root. This is your new root, which will be passed at IntTree node, and it will go over here, and your overall root is updated. Now your overall root looks like this. Now user said, this is your root. I'll just write R as overall root. Now user said add method again, and it says add, let's say 5. So your value is 5 now. User wants to add, value is 5. User said add 5. You go inside your add method. You have overall root equals to add method fast 5 and overall root. This is your overall root now. And you said add 5. Now your value is 5. And overall root is again starting with 8. This is where your root is pointing, because whatever you have to do is 8 is in charge of everything, because he's the root. So your root is 8 and holding the rest of the tree. Now you go inside if root equals to null. Nope, our root is not null, it's holding something. You go in else if root dot data is less than value. Is your root dot data, which is 8, is less than value? What is value? Value is 5. Is that true? No, root dot data is not less than value. Okay, let's go in else if. Is root dot data is greater than value? Is your root dot data, which is 5, is greater than root dot data 8 is greater than 5? Yes, that's true. This is true. 8 is greater than 5. This else if is true. Then you said, okay, go to root dot left. So root is now updated to not right side. So your root is now root dot left. It's over here on the left side. This is your root, and you are making equals to add method. Again, go to the add method with 5. Yes, it's 5 and root dot left. Now root dot left, and your root is now root dot left and value is 5. You check if root equals to null. This is your root where root is pointing at. Is your root null? Yes, root is null. And you said, okay, if root is null, then root you are equals to new IntTree node. And how you create new IntTree node? You create new IntTree node like this. You said you are passing a value is 5, and you have with new IntTree node left and right are null. And this is your base case. It will exit your code. It will return root. This is your root. new root in data type is returned, and it has updated your overall root. So now your overall root looks like this. This is the binary search tree you have. Is it sorted? Yes, the binary search tree is sorted. Let's make a last call one more time. User wants to add. User wants, give me a value you want to test. It's your choice. Put a value in chat you want to test. Value you want to add. Give a value. User said add method. What value you want to add to your binary search tree? 3. Let's do 3. Value is 3. Overall root, you are equals to value and overall root. Same, this overall root will be passed. Value is 3 this time. You have a value 3. Your root is pointing at 8. This is your root. Now, private method. Is your root null? No, my root is not null. Okay, go in else if root.data is less than value. What is root.data? 8. Is 8 is less than value? Value is 3. Is 8 is less than 3? Nope. Go in else if. Is root.data, which is 8, is it greater than value, which is 3? Yes, this is greater than value. Root.data is greater than value. Then go to root.left. So update your root to the left side. So your root is now updated to the left side. So root is now on the left side. So root is pointing at 5. Add value, add, you are making a call. Because of this, it will go back to this method, and with a value 3, same value is not changed, but root is updated. Root is now root.left. Root.left, which is 5. You will check again. If root equals to null, your root is null. Nope, root is not null. You will check if else if root.data is less than value. Root.data is 5. Is 5 is less than 3? No, 5 is not less than 3. Else if root.data is greater than value. Is 5 greater than 3? Yes, this is true. Root.left, you are equals to, update the root.left equals to add method. Again, you are making a recursive call again one more time. Recursive call is made and you are passing value, which is 3, and root.left. Go to left side of this root, which is root.left. So root.left is this one. Okay, now you will check if root equals to null. Is your root null? Yes, root is null. Then root, you are equals to new IntTree node. And how we create the IntTree node? We create IntTree node like this. Add the value, which is 3, and make left and right as null. And it will return your root. This is the updated root, and overall root will be updated. And the values are added in sorted order. That's it for the add method. Any questions so far?